ID is flowing. If you make VBS more negative than VBS1, VBS2 more greater than VBS1, then you will get. Otherwise, you can write in this way also: VSB2 greater than VSB1 greater than 0. Then also it is correct. Both the way it is correct. So you see that how threshold voltage is increasing. Here is further VBS or VSB3 greater than VSB2 greater than VSB1 greater than 0, means the more negative, it is more negative. The most negative is VSB3, then this one, then this one. Okay, so this is the significance of this. Threshold voltage increases if you increase the VBS becomes more negative. Now, one numericals, let us try to understand quickly. Then only things will be more clear to you. Assume that here is a two. Actually, it is a two experiment. One with P MOSFET, one with N MOSFET. Two assignment or question actually. Okay, so everything, every values within the parenthesis is for P MOSFET. Okay, for example, this one is for P MOSFET, and outside the parenthesis is for N MOSFET. So assume that an N MOSFET or a P MOSFET has a W/L ratio of 5 micrometer by 1 micrometer, and that the large signal model parameters VT0. VT0 means, tell somebody, VT0 means what? Yes, Harshvardhan, are you there?
Sir, threshold voltage when VBS is 0.
VBS is 0 or body or source are tied together. Okay, there is no potential difference between source and body. So VT0 equals to 0.7 volt for N MOSFET, for P MOSFET is minus 0.7 volt. Kn prime equals to 110 microampere per volt square. This is for P MOSFET. Gamma equals to 0.4 e to the half. And this is for N MOSFET. P MOSFET it is 0.57. And gamma is what? Body effect coefficient. Are you remembering? Then lambda equals to 0.04 volt inverse. In case of P MOSFET is 0.05 volt inverse, and 2 phi is 0.7 volt, and this one is for P MOSFET is 0.8 volt. Here mod is used. Okay, see, yesterday we are denoting it with what? Tell me. Twice phi f we are writing. Okay, or also I wrote phi f p. Phi p was what? What is the value? Can you tell? First of all, it is positive or negative? Tell. Phi f p and phi f n. It is phi, not q. Phi f n. Tell what is the value at 0.25 micrometer technology node? What was the value? Yes, remember
minus 0.3.
Minus 0.3 for which one?
Sir, for N MOS.
N MOS. So which one? This one or this one?
Sir, I am confused between substrate and MOSFET.
Yes, N MOS for substrate is what? Tell me.
Sir, P type.
This is the correct answer. Okay, phi P is negative and this is minus 0.3 volt. This is for N MOSFET because N MOSFET substrate is P type, right?
Yes, sir.
Could you understand? Yesterday also we have discussed, and this is for P MOSFET. P MOSFET's substrate is N type. N well. Remember that. Okay, N well. So it was plus and this 0.3 it was approximately. Okay, both are assumed same. Here it is little difference, and we'll discuss why it is. Okay, here 2 into 5 f. Here it is only 5. F is not written. So 2 5 is 0.7, and here it is given 0.8. The technology generation is different. Remember that. Maybe it is 1 micrometer technology or 5 micrometer technology, and this value was given for 0.25 micrometer technology. Okay, it is technology dependent because the phi f depends on what? Doping concentration? Yes or no? What is the equation? Phi f was given as what? Pt into something natural log of ln of what? Na by some ni, something like that, or otherwise? Yes or no? Possibly it was interchangeable. I mean, ni by na, nd by na, something like that was there or not? You go back and see that slide. It will be more clear. Where it was? Yeah, here na by ni. This is the. But if you consider specifically for p type substrate Vt, natural log ni by na. If it is n type substrate or NOL, then it is Vt ln natural logarithm of nd by ni, right? So this thing is higher than this one, so it is a positive quantity for P MOSFET because substrate there is N type, and for P type substrate, that is N MOSFET, is going to be Ni by Na. So in that case, it is negative. Okay, because this is higher concentration than Ni is the intrinsic concentration, which is 10 to the power something. I mean, 1 to 10 to the power 10, whereas or 1.5 to the power 10, whereas Na will be at least say 1 to the power 15 or so. Okay, or 15 or 16. So it will be a negative quantity. And value wise, here for see minus if phi f is equal to minus 0.3 volt for 0.25 microwatt CMOS process P type silicon. Okay, P type silicon means phi P for N MOSFET. So you have said correctly. Little confusion. So this is what we have written, but it is for 5N and 5P. It will be a little different. So you have to remember. You have to remember now. Now, coming to the actual question. Further, what is that? Given if the drain gate shows and bulk means body voltages of the n-channel transistors are 3 volt. Per P MOSFET is minus 3 volt, 2 volt minus 2 volt, 0 volt, 0 volt, respectively. Find the drain current for both types of MOSFETs. Okay, so what is VDS in our case? Drain voltage is what? So sorry, we know that VDS, if greater than equals to VGS minus VT, then it is in saturation region. Okay, so this is VGS minus VT. VG is this voltage, and threshold voltage we have mentioned here as 0.7 volt. So 1.3 volt is the VGS minus VT, and since VDS is 3 volt as given here, drain voltage. Okay, so VDS is greater than VGS minus VT, means 3 volt greater than 1.3 volt. So it is saturation region. MOSFET is in saturation region, and VDS I have put SAT. It is indicating VDS, that it is that VDS which is applicable for saturation region operation. Okay, greater than VGS minus VT. So we have to write the current equation which is applicable for saturation region. So this is the ID. ID is equals to Kn prime W by 2L BGS minus VTN whole square into 1 plus lambda VDS. Lambda VDS is coming because of you want to capture this CLM. Okay. This Kn prime is what? Mu n C ox. This is the value Kn prime. Kn prime is this. Okay. So it's a spice parameter. We'll list all the spice parameters later on in a table. Now putting these values, say Kn prime is given as Kn prime is given as 110 microampere per volt square. So this is this one up to this. Then WE is given as 5 micrometer width. Then this is VGS minus VT. Already you have seen here this one. And 1 plus lambda. Lambda is 0.04. VDS is 3 volt. So divide by 2 into L. Okay. And current will be, if you calculate with your calculator, it will be 520 microampere. So IDS is 520 microampere. If your device is biased in this way, and if it's spice parameters like VT0, lambda, gamma, etc., are Kn prime, etc., are given. So can you solve this kind of problem in the exam? Tripathi, could you understand, or any doubt? Anybody has any doubt? We have just discussed the equation, derived the equation also. Tell, somebody tell. Somebody tell. Is it understandable?
So the saturation region part, can you explain again?
See, we have already discussed. Let me delete it. We have already discussed that MOSFET can be firstly off or on. Okay, on. When off, condition is when VGS less than VT. Understood? Let us talk about N MOSFET. So VTN. Opposite is the case for P MOSFET. It is for N MOSFET. N MOS for P MOS what? Tell me what? VGS greater than VTP. Understood? You have to keep in mind the sign also. Sign of the MOSFET threshold voltage. Now, if MOSFET is on, there are two cases. One is the MOSFET will be in saturation region or linear region. Linear region, if an ID is here, ID equals to 0 because there is no inversion layer formed. ID equals to beta, you will understand, beta into VGS minus VT into VDS into VDS. Let me put another bracket, minus VDS square by 2. Beta is standing for what? Beta equals to mu n C ox W by L. Okay. Now, and the condition for this linear region equation is what? VDS less than VGS minus VT. Of course, this condition is always there. The VGS should be, first condition is VGS should be greater than VTN. That you have to check first that it is in on state. Once it is on state, then only you will try for checking whether it is working in saturation or linear. So other condition is ID equals to beta by 2 VGS minus VT whole square. And if you take CLM into consideration, then you have to add another term, that is 1 plus lambda VDS. Okay. And condition for this is VGS greater than VT, VDN, and most we are discussing. So VDN, everywhere you can put VTN. Then next is VDS greater than equals to VGS minus VT. Now understood? This discussion was there. Again, I am repeating for you. If anybody have any doubt, tell me at this point. Tell. Someone was asking. Is it understood?
Yes, sir.